Hi class, this is Professor Smith. I'm going to be doing a movie on discrete versus continuous variables. Before we start this exercise, let's use the ebook to make sure that we have an understanding of the concepts or the terminology. To the right, there's an icon that looks like a book and it says ebook if you hover your mouse over the icon. There's a video on discrete versus continuous, so you could watch that. But we're going to open up the ebook. So now I've scrolled down and I'm taking a look at a table of information, and looking at this table we want to introduce some terminology. In this particular example we have 6 voters and their political affiliation as well as their age and if they voted in the last election. So they ask us, well, how many individuals are there? Well, there were 6 individuals because that's how many they had in our table here. And then it asks us to identify the variables. So the variables would be this heading of this table. Political affiliation, because that's a characteristic of the 6 people that were in this group. Age, as well as if they voted in the last election. So those are examples of variables. And then it says, what are the data for individual number 3? So individual number 3, the data that we have is that the political affiliation was Democrat, their age was 21, and they did not vote in the last election. If we click answer, it will tell us that there were 6 individuals, political affiliation, and then Democrat, so forth and so on. So now we need to talk about qualitative and quantitative variables. Distinguish between quantitative and qualitative variables. Variables that can be divided into 2 groups, qualitative or quantitative. In ALEKS, you'll see qualitative used interchangeably with categorical. And categorical is a great way to think of qualitative data because it means you could put the variable in some kind of category. Quantitative variables you can think of as quantity. Those are things that you measure or that you count. So you can think of quantitative as things you measure or count, and qualitatives are qualities or things that you can put into categories like the color of their eyes, the ranking of a person that wins at the Olympics, bronze, silver, or gold. So those are categories. All right. So let's go ahead and look at qualitative and quantitative variables. So we're going to take a look here at a person's age. And a person's age is quantitative. A person's place of birth, like I was born in Oakland, California, so that would be qualitative. The mileage in miles per gallon of a car, so that's measuring the miles on the car, so that would be quantitative. And the color of a car would be qualitative. So age is quantitative. It tells how much time has elapsed since the person was born. City names are qualitative. Mileage is quantitative and color is qualitative. So now what I'd like to do is talk about discrete versus continuous, which is the exercise we're working on. So let's scroll down and discuss objective 4, which is discrete and continuous. So it turns out quantitative variables can be broken up into 2 categories, discrete or continuous. So you said, well, how do I know what discrete? Well, it says here that discrete variables are those whose possible values can be listed. So for example, -3, -2, -1, 0, 1, 2, 3. Those are values that are in a list, and the list can have negative numbers. Continuous variables in principle can take on any value within some interval. And they give an example, for example, of height. A person isn't just 2 feet and then go to 3 feet. They can be any range of distances or heights in between when they're a toddler as they're growing into 1st grade and 2nd grade. They don't jump whole feet, even though children have had growth spurts where they grow quite a bit over the summer, which can be extremely painful if you've ever had a growth spurt. But the range of values are not from a list. They could go from 2.1 inches to 2.2 to 2.3 to 2.25 to 2.037. Well, that's going down, but That happens when you get older. You do shrink, you lose bone mass, and your height, are not as tall. But you can see that you can go take on and can be any interval of values. And I ended with 2.3, but it could have been the 2.357 or 2.368 or 2.379432789. So it takes on a whole range of values from this interval. So let's go out to our problem in ALEKS and attempt to do it. The body temperature measurement of a participant in a lie detector test. So this is measuring the temperature of a person. So whenever we're measuring something, it's usually continuous because it can take on a range of values. Here is the number of occupied tables at Zito's Cafe at 8 p.m. next Friday. So you usually, when you talk about a table being occupied, you would say there's one table occupied or two or three, depending on how many tables are at the restaurant. So that would be discrete. You don't say half of table is occupied, even though there might be, and not everybody's taken there. But for the hostess, they're not going to sit somebody at a table if someone else is sitting there, whether it's one person or two or four or five people sitting there. That table is considered occupied, whether the whole table is filled up or not. And again, the key thing here is number, the number. And you have to be careful. You can't always just say, oh, number is always going to be discrete. You do need to use critical thinking. In an experimental study, the participants estimate for the height of a 3-meter projected 12 meters away. So they're trying to estimate the height of something when it's 12 meters away. And so in this one here, it would be continuous because the range of values could go from, they could estimate it to be 4 meters or 5 meters or 2 meters or 1 meter. All right, the amount of time that customers spend this week listening in to telephone hold music while calling 1-800-parcel. So how long you're on the phone. And that could be, you could be on there a minute, or you could be a little more than a minute, or a little bit more than a minute and a half. And so that takes on a range of values. So that would be continuous. So in this case, for the two continuous cases, we had something that you measured, or you can think of time. Time is also going to be considered continuous, as well as money, even though you think, well, no, money, I mean, I only have $2.50 in my purse, but it can take on a range of values depending on what you're measuring. So if you're measuring the average salary, it could take on a range of values. And the salary that students earn once they graduate from college annually could take on a range of values. So that's why money is considered continuous. So let's check our answers and do another. We did well. We got correct. So let's do more practice. So the number of students in a class of 35 who improved their score from the first midterm to the second midterm. So these are the number of students who improve. In other words, they did a certain way on the first midterm, but now they kind of learned about how the teacher's going to test, and they want to know how many of those 35 improved. Well, since it's only from those 35 students, that's why it's considered discrete. The number of tickets purchased by a caller on a Rose Bowl ticket hotline. Again, it's the number of those tickets purchased, so that would be discrete. And again, the number of children in a household is going to be discrete, even though I used to tease about my siblings and say I feel like there's only half of them there because they have half a brain. But it's a whole person, and so it takes on a discrete number of values. And then the total snowfall amount in Minneapolis this year. And so that would be continuous. Let's do one more. The actual length of a roll of plastic wrap advertised to be 30 feet long. So it's advertised to be 30 feet. You go out and pull a few of those and see, well, how long are they really? And so that can take on a continuous range of values. So again, it's length, something that you measure. The number of tickets purchased by a caller on a Rose Bowl ticket hotline. Oh, we see that again. So that's discrete. And the number, oh my goodness. These are like the same problem. So you know what? When I'm in student view, they don't vary them as much. So I apologize. And then the number of occupied tape. Oh my goodness. It's like identical. Yeah. So there. While I'm here, I'll just tell you about the Message Center would allow you to send a copy of this problem. If you didn't submit it and didn't know how to do it, you could send that and I would get a copy of it. And then there's a dictionary too. So if you forgot, now what is discrete again? I know she said it in the movie. You could click this dictionary for discrete and you can look up a statistical variable, whole number, and you can do additional terms as well. So if we clicked on this statistical variable, it would have this guy here. It doesn't have discrete in here. That's interesting. The book. Let's check our answer. Let's see if the next one maybe is a little bit more varied. No, this is a little different, even though there's some repeats. The number of students in a class of 35 who improve, that would be discrete. The cranial capacity, space inside the skull of a human skull, that's continuous. Again, that's something we measure and it can take on a range of values. The height of a 5th grade boy, again, continuous. And the time for a participant to identify the color. So the next one is the time for a participant to identify the color of the letters when the word red is shown in green letters on a computer screen. So that, again, is time, something we measure, that would be continuous. So I hope this movie on discrete versus continuous variables was helpful for you.